Hello, my name is Muzin Wadia and I'll be presenting my task 1, that is prediction using supervised ML, that we will be using to predict the percentage score of students based on the hours of the study. So let's start. First of all, we will be importing all the required libraries to solve this regression problem. So Pandas has a lot of libraries in them, and what are we going to use are the Pandas, the NumPy library, the matplotlib.pyplot, which will be helping us to plot different graphs and present the data, and Seaborn especially, which is a great way of data visualization, sklearn, which will be helping us with the regression model and to predict the score of the student. First, what we will do is we will import the data frame that is provided to us in the CSV format or the text format. Over here, I have used the variable data1 to import it or to assign it as studentScore.txt. Now, what I'll do is I'll check the data type of the data1 data frame. That is, you can see over here that it is pandas.code.frame.dataframe of data frame type. Now let's check what it is in there in the data1 data frame. We can see that the data frame is not very clear, but it shows two values, that is the hours and the scores of the students. So now what we will do is we will quickly convert this data frame or try to split it. So first what we do is we take the column hour scores of the data1 data frame and we convert it to the string type s-type str. Now what we do is split that one column of the data frame into two. What we do is we assign the data1 hours and scores one column, that is the second column, and now we split this one column into two by using .str.split. Now let's check what is there in the data frame. Data1.head shows up the top 5 datas of the data frame. So you can see the index 0, index 1, index 2, index 3, index 4, it's 5 data frame, 5 data points available. Now what we're going to do is, since we created two separate columns, that is the hours and scores, we are going to drop the previous one column that had our score as its name and which had data in it in a very chaotic manner. So we drop that column by using .drop method. We input the column name, our scores, and in place equals to true, as we want to keep it forever in the data frame. Now let's check. Now you see that data1 just has two columns, that is hours and scores, and we can see that data in a very clear and a very systematic way. The type of the data is although different. If you see hours, it's object, scores is object, which is not supposed to be. If we need to calculate or manipulate the data, we really need the data to be in the integer format or the float format, because those two data can be manipulated or carried out different operations on it. So now what we do is converting the object type to numeric type. It's very easy. First we select both the columns, scores and hours, from the data1 data frame. Data1 hours scores column .apply.pd to numeric. Now what this does is it converts the object type into numeric type. Now we check the data type of the data1 data frame columns. Now we see that float 64 and N64 are the two data types. So now we can easily go ahead and do the mathematical operations. Now let's check if there are any null values. The reason we check or go for null values is because null values actually are the bugs, or you can say something that actually destroys our data in terms of data visualization. Null values do not provide any source that can help us, so we just check whether it is there or not. We see that ours doesn't have any null value. The scores column also doesn't have any null values, so we can go ahead and do it. SNS.dispLot.data on hours. Now this is a very simple way to check the outliers in our data. So if you go to see that the first thing we do is we check the hours column and we check whether it has any outliers or not. It's quite clear that the data doesn't have any outliers which lies on the extreme points of the graph, if you go to see, which is not there. So we don't have to worry about it. Also we check for the scores column, whether there are any outliers in the scores column data, and we get to see that there are none because there are no data on the extreme points of this plot. So let's now check the correlation. Correlation method actually helps us to understand how much one column of a data or one variable in a data frame depends on the other variable of the data frame. So now we have two variables, that is the hour and scores. So what this does is check the correlation. Now if we put the hour as 100%, so 97% it depends on the hours of the study. So the more you study, the more you will get. And if you see over here, the more score you get, the more score, if you want to get the more score, you got to study the most, that is 97.6%. Now, this is just a conclusion that there is a positive correlation and a linear relationship between hours and scores. As hours increases, scores increases. Now, what we got to do is we got to perform a linear regression. So we just take out the values in the x and y, which we want to use as test data and the train data. So what we do is we place the test size, the test data as 20% of the data, and the rest of it, that is the training data, will be the 80% of the data, since we need to comply with the regression model. So now we use the sklearn.linear model. You import the linear regression which we will need to predict the score of the student. So this is the basic syntax of how we go ahead predicting the model. So this we use to train the model. So training is completed. Now what we do is we use the regression line plot to plot a line which is nearest to the data points available. What this line will do is it will actually create, first of all, we will create a scatter plot. The scatter plot will be created, and what we have to find out is that one line that will be the closest to every point on this scatter plot. So what this line does is helps us to create a line which will be at the minimum difference from these scatter points, and then it will create a line which will show us the most optimal value of the relation between or the prediction of the scores. Now with our model created above, we will just have a look at the actual and predicted value. Now if we go for the actual one, our model predicts value that is 16.68, 33.37, 75, 26.30 and 60 and 62. So you see it's quite nearby, and it is decent enough to calculate or predict the value of what we want. So now let's find out the score for students who studies for 9.25 hours as given to us. So now we just input the value was 9.25 and we go ahead with the regression predict method. And then we go to see that the number of hours when 9.25, the predicted score will be 93.6973. If you go to see above, you'll actually get to know that the more you study, this is 9 hours over here, this is 18 hours over here, and it's just about 9.25 hours. So we go to see it is coming to an accurate answer that is around 90%. We get 93.69%. So at the end, we just check the mean absolute error, or how much error can be caused, that is 4.18. So that is all that we have to know from this prediction model: how to train, how to test, and how to predict the value through it. Thank you.